for the experiment is to use linear A track to investigate Newton's second law of motion. The theory of the experiment is Newton's equation of motion for a point of mass m to which a force F is applied is given by the following: F equal to ma. As indicated by figure 1, when m2 is released, both objects will accelerate. The two masses will have acceleration a of the same magnitude because they are connected as a single system by unstretchable massless string. An analysis of the motion of the system assuming that Newton's law of motion are correct is set out in the next slide. As shown in figure 2a, there are three forces acting on m2. The force from the contact of the frictional surface pushing up on m label T. The contact normal force and the gravitational force cancel each other, meaning the total force acting on a long vertical direction on m is equal to 0. This leaves the tension in the string as the total force acting on m2. Newton's second law say that m2 will accelerate and give the equation T equal to ma. Figures 2b shows that there are only two forces acting on m, namely the gravitational force W equal to mg in downward direction and tension that pull m outward. By using Newton's second law, F total equal to T minus mg minus m1a. Eliminating 1 from equation by substituting equation 2 into equation 3 as a single equation for the acceleration is written as m2a minus m1g equals to negative m1a, which is Newton's second law for a system of mass m2 plus m1 with net force applied to it is the equation of a straight line with a slope equal to the mass of the system, ma2 plus m1. So if you are vary the mass of m, keeping the gravitational force acting on the system and the acceleration system, notice that the tension has been eliminated from the final equation and is not needed in the analysis since we are only concerned with force acting on the system, not acting between objects within the system. Acceleration A can be determined using equation x equal to v 2t plus 1 over 2 at squared. If the glider starting from the rest move a distance x meters along the A track in time of seconds, the acceleration of the glider can be found from x equal to 1 over 2 at squared or A equal to 2x over t squared. Substituting equation 1 into equation 6 gives x equal to 1f over 2mt squared.
The apparatus needed for the experiment are a treadmill, blower, pressure tube, gliders, flat photo kits, masses, mass hanger, string, and pulley. The apparatus was set as the picture shown below. This is the procedure of the experiment. First of all, the linear air track set was assembled as shown in figure 4.1. The pump was switched on to let the air blow through the track for several minutes. The track was balanced by adjusting the screws on the legs of the track so that the glider stays stationary and does not glide to either end when let go. Third, one hook at one end and a flag on top of the glider was inserted. The mass of the hanger and length of the flag was measured and recorded. One end of the string was attached to the hanger and the masses were placed with a mass of 20 grams on the hanger and put the string over the pulley. 7. The glider was positioned exactly before the photo kit. The glider was released and the time shown on the photo kit was recorded. Step 7 was repeated 2 times for each masses to obtain the time average values. Lastly, the procedure was repeated 4 more times with 20 grams each added to the hanger. So this is the table results obtained from the experiment, with the length of legs 0.096 plus minus 0.00051 and length of hanger 0.02 plus minus 0.065 kg. So this is the analysis of the experiment. Question 1. Plot a graph of weight force versus acceleration. to plot the graph, we have to find maximum point and the minimum point. Also from the graph, we can obtain the percentage error of the experiment. For y-intercept, we put weight force Fn, and the x-intercept, we put acceleration. Question 2. What does the graph tell us? The higher the force exerted on the object, the higher the acceleration. This shows that Fn is proportional to acceleration. Question 3. Do these results support Newton's second law? Yes, because the acceleration is proportional with the force which suits Newton's second law, which is F equal to ma. Question 4. Discuss any sources of error. There might be errors like human errors and measurement errors. For human errors, students need to hold the hanger and slotted mass to avoid it from falling, while accuracy in measurements could caused by the surroundings. For instance, the glider and the flag need to be made sure did not move when the air motion is on before conducting the experiment.
Discussion. Based on the data collected, the weight force of hanger and slotted masses will increase due to the increasing of the acceleration. This proves that weight force is directly proportional to the acceleration from the plotted graph. It's shown that the relationship between the force and the acceleration is related to the Newton's second law of motion. Newton's second law of motion is a quantitative description of the changes that a force can produce on the motion of a body. Therefore, when the weight force of hanger and slotted masses is increasing, the acceleration also increasing. A few possible errors that could have been made throughout the experiments is that for the uniform acceleration experiments, the spring kicker was not working. Thus, the cart had to be pushed by the hand up the track. This could have led to the not completely accurate readings for the data collected for that graphs. Another source of error that could have occurred was the theories like this do not account for other possible conditions such as friction, temperature, altitude, and etc. This means that these conditions could affect on how fast or slow the cart moves along the track. Lastly, conclusion. In conclusion, the usage of linear air track helps to investigate Newton's second law of motion. The theoretical mass of the gliders that have been measured was 0.196 kg. The mass of the gliders based on the graph was 0.2 kg. So, the total of the percentage error that occurred in this experiment was 2%.